Let's welcome our next speaker, who is Dushyant Dushyant Dubey. Oh, sorry for my really poor pronunciation. I need to come more to get familiarized with the names. His title for today is Data-Driven Insights into Thermo-Viscoelastic Behavior of Additively Manufactured Short Carbon Fiber Reinforced Nylon Composite for High-Performance Structural Application, and he's from IIT Delhi. Let's welcome Dushyant.
Good morning, everyone. My name is Dushyant Dubey, and I have two PhD supervisors. I am from IIT Delhi, India. My title is Data-Driven Insights into Thermo-Viscoelastic Behavior of Additively Manufactured Short Carbon Fiber Reinforced Composites for High-Performance Structural Applications. It's a long title, by the way. So, I work in 3D printing, and additive manufacturing is a big term, but as it contains right now 4D printing as well. So the buzzword is 3D printing. 3D printing is a process of making three-dimensional objects from a 3D CAD model using layer-by-layer phenomena. It is opposite to modern subtractive manufacturing. It uses variety of materials like in the form of liquid resins, solid filaments, powders to make a part or product. This is very basic. We have to first make CAD file, then convert it into STL, then we slice it into the layers, then we make G-codes, and then we give that file to 3D printer, and it prints. Since we are in Dubai, so let me tell you that Dubai has the world's first 3D printed building in the world, which is whose name is Office of the Future. It is a first fully functional 3D printed building in Dubai. It was inaugurated in 2016. This is world's largest 3D printed building in Dubai, which is Dubai Municipality building. And everything in Dubai is a big. Let's come to our agenda. In this work, I perform dynamic mechanical analysis on my 3D printed specimens. So DMA is a technique used to analyze mechanical properties of materials, especially response of a material to an oscillating stress or oscillating strain, as a function of time, temperature, and frequency. It is valuable for characterizing viscoelastic behavior of materials, including polymer, rubbers, composites, and biomaterials. It often performs over a range of temperatures to study the material's behavior under different thermal conditions. Three are the main parameters by which we analyze DMA properties: storage modulus, loss modulus, and damping factor. So this was my working methodology. I took nylon carbon FDM filament, then I printed with FDM 3D printer. Then I performed dynamic mechanical analysis in 3-point bending mode. Then I took that data and applied machine learning models to optimize my printing parameters. So this was a queue, like I trained my models and validated them, hyperparameter tuning. Then I selected my best model, and then with that particular model, I optimized my parameters. So as you can see, this is a storage modulus. So you can think like a spring. If you have seen the pen's spring, when you give some vibration to it, it restores the energy. So basically, storage modulus is material's ability to store elastic energy, and we have no intent like whether I want higher amount of storage modulus or lower amount of storage modulus. Whether the storage modulus is high or low, each value has its specific applications. So I printed 27 specimens, and with the different infill 3D printing parameters. So these are there are the few specimens which got the higher modulus values. There are the samples which got lower modulus values. So high modulus values have different applications like very stiff, high E dash means very stiff material. Medium E dash is semi-stiff, and low E dash is very soft material. Conventional applications are like in the car, you have seen the internal dashboard frames, interior panels, seals, gaskets, and soft polymers. So these are the conventional applications. I have my own 3D printing applications as well for this work, like load-bearing 3D printed brackets, functional 3D printed enclosures, and flexible 3D printed hinges. Similarly, loss modulus, it is material's ability to dissipate energy as a heat. If you have seen the car shock absorbers, when you sit in the car, whenever you face any breakers, so the shock absorbers do, it releases the energy in the form of heat. So you feel very less less thing on breakers. So high E double dash has different applications. So like if I want to make a good amount of good type of shock absorbers, I will say I need high E dash value. If I want to make moderate damping, I will say I need medium E dash value, E double dash value. Similarly, for low, it's a poor damping. Damping factor is the ratio of loss modulus to the storage modulus. So it tells you basically how effectively a material damps vibrations by dissipating energy relative to elastic storage. So for getting the optimum parameters, I applied 9 machine learning models from all major ML families to see whether it fits to my data or not. So linear regression, polynomial regression. So some linear regression models were there, some non-linear models was there. So since my graphs, you can see there is so much of non-linearity. So I'll have to check so many models to capture my non-linear behavior of my curves. So as you can see, I have mentioned R square value and RMSE values as well. So to get the best model, we should have the maximum R square value, and MLP, which is multi-layer perceptron. This ML model got the highest R square value. So this is the comparison. In the last graph, you can see that MLP has the highest R square values, and subsequently the performance has been decreasing. So I selected MLP for storage modulus. Similarly, for loss modulus, I trained all the models, and one thing, I tested my data like 80-20. So 80% of my data was used for training purpose, and 20% was for validation purpose. So in this also, MLP got the highest value, which is 0.986. So this is the performance for loss modulus. So MLP, multi-layer perceptron, was giving the highest efficiency. For damping factor, the case got bit reverse. I got HGB. This model gave me the highest amount of R square value. Basically, this is a histogram-based gradient boost regressor. So what I wanted to do, I wanted to optimize my parameters, that which parameter is affecting my dynamic mechanical properties. So in storage modulus, if you can see, in all the graphs, you will see test temperature is the highest value. Okay. So for storage modulus, I got layer height was giving the best optimum parameters. For loss, it was layer height, but you can see the sequence. It is different in 10 delta. So this was my data. I will skip. So if you want to see my work, so this is a website. What I did, I have made this website, and there were some parameters which on which I trained. But in machine learning, you can predict new graphs by changing the values. So if you slide these printing parameters, you will change the curves. Yeah, thank you.